Okay. Hello guys. I'm Mrinal Joshi, the manager of the Electronics Club. So first of all, hope you had a good journey from your college till here. First I'll tell you about the tech scene at IIT Bombay. We have these various, you can say, bodies or clubs. So the STAB is the main one which has 6 or 7 clubs. The Electronics Club falls under this. And we have these 3 independent bodies, the IITB Racing, AUV team and Pratham. You must have heard about Pratham, like has it the student satellite? Yeah. So around 5 years back, this organization was formed and this was the first student satellite project happening, the first one in India. AUV is a competition, like this team, the RoboSoft competition happens in San Diego. They build an underwater glider and they have been working for the past 1 year. It's a 20-member team working for around 18 months on this. But today I'll focus mainly on STAB. This is the Hobby Electronics Club of IIT Bombay. So these are the 7 clubs under it. As you can read, Electronics, Robotics, WNCC. WNCC is the Web and Coding Club. Aero Modeling, Kritika, the Astronomy Club. Don't ask me why it's called Kritika. Next, the Maths and Physics Club and Technovation. I guess the names are quite suggestive of what they do. Technovation are mainly, they handle the big projects, semester-long or year-long projects, and it's innovation in technology, so Technovation. Yeah, about the Electronics Club. So first of all, what is this? It's a club. It's a hobby club and it's the largest platform in the institute for anyone interested in electronics. We start from the basics, so even if for the first year students, even if they have no prior knowledge, by the end of the first year, they gain quite much. So what does the club do? These are very broad activities that we have. There are many hands-on electrified sessions. We like calling it electrified, just for it. And then lectures and workshops by students and faculty, various competitions, summer projects, work visits, and many more. Yes, so what do the students gain? Here, mainly they develop the passion in electronics via various sessions and talks. So they build their own circuits, and we learn cool stuff like image processing and microcontroller coding, which we've always heard from the first year, but here you actually learn it. One very highlight or important point I would like to add is we have a very good Google group, and all the members stay connected through this, and the Facebook group is also active. The Google group also acts like a forum for all of us, where students from various years post their doubts. Alumni who have passed out around 4-5 years back, they're answering the questions to it. So it's really helpful that all the members keep connected. And of course the sessions on various topics, where the talks are given by the Tech Janta, by the Lingo here. So, now I have a short video for you. We had made this video for the freshman orientation this July. Okay, I'm sorry about that, not able to open the video. It was basically a fun video showing all the stuff that I had just spoken about, the sessions, the talks, the work visits. So we'll carry on. ITSP, a major initiative started by STAB, all the clubs together this year, was the ITSP, the Institute Technical Summer Project. Here freshmen, mostly freshmen, at the end of the first year, got together in teams of 3 and 4, stayed back in summers for this, for around 45 to 60 days, and made very cool ingenious projects. Like some of the projects would be a 4-track board. This was an all-terrain vehicle. Now again, I'm sorry the video won't play, but you can see the pic here. It's an all-terrain vehicle where they could independently move the 4 arms of it, climb onto surfaces around 4 books, high on stairs. It could climb up stairs. So miniature version of a tank or that way. Then the other interesting projects, transmission through lasers. Like we use laser from one computer to another, data transfer, and the further, they made a further advancement in this, that the receiver could be automatically oriented as per the transmitter. So, just transfer, leave the receiver as it is, it will align itself and read the data. The drum piece replicator, one of my favorites. In this, they made a real drum set, and whenever you play an audio file, the corresponding, we have the snare, the three parts of the drum. So the corresponding drum lights up, and then when you hit that, the same sound is created. So it's teaching you how to play the drums. The gaming controller, 610s, okay. The robotic arm was also a cool project, with a functional robotic arm. And yeah, about this ITS team, the major factors were we had very good mentorship. Students from 3rd, 4th year, PGs, they helped us in the mentorship. We funded all the projects, and yeah, it was a great learning experience for all the participants. A very important thing was like 390 freshmen took part in this, and not only from electrical engineering department, people from metallurgy, civil, computer science, everybody was interested, and yeah, it was a great success. Okay, so again these videos. Another project, the wall following board. This guy moved the cardboard box, and the board kept on rotating according to it. It detected the wall and kept rotating. The self-parking board. This is a nice one. As you can see, there's one small parking lot there, and the next one is a bigger one. The car goes along, it detects that it's a small one, it cannot get in there, so it goes forward, detects that one, and comes back and reverse parks into the bigger slot. The Rubik's Cube solver. It took around 2 minutes. We'll try to make it shorter, faster one next time. Okay. So now about the sessions. For the freshmen, we have a typical set pattern of sessions each year. As I said, we like to call them the electrified sessions. They're the hands-on sessions that take place in the electronics lab. 1, 2, 3, they go on. So, like the first one is just basic, introduction to resistors, capacitors, the CRO, how to work inside a lab atmosphere. And the second one could be an analog one. Third one about gates, digital logic. So that's it. Next, around mid-September, we introduced a microcontroller, the Arduino one. Right? So that coding session. Then tinkering sessions are everyone's favorite. We like open up laptops, printers, just get together and study them. Bots from scratch. Yeah. For the seniors, these are few of the sessions. I have just noted them down. The PCB design, Eagle sessions, embedded system, wireless modules. Yeah. This year I introduced the circuit jamming sessions. Here the main concept behind it was people getting together, opening up circuits and hacking them or jamming them. And finally trying to make something on your own. Not just studying them, but breaking them and making a new one on your own. So we had a radio jamming session in which first we got some radios. It was not a boring one-on-one talk like this seems to be going on. I'm talking and you're just listening. So in the circuit jamming session, there is just 1 or 2 seniors, but finally the students opened up the AM radios, they studied the circuitry inside, they googled, they browsed on how the circuits might be. And then we taught them how you can make a simplified radio on your own. And then advanced microcontrollers, and yeah, everybody's favorite, the image processing. Okay. So enough of giving fun days. We have major competitions, on-the-spot competitions, and huge prizes for them. So for the freshies, we have the first competition. I'm sorry, the name keeps on changing, so I wasn't very sure which one to write it. Like for the past 4 years, we've been calling it Tech 1, Trackmania. Trackmania is a game, I'm sure everybody is aware of that. So it's like you make a manual board, we give you a nice track, you follow that and win points. The second one, the line follower, which happened just yesterday, this weekend. In this, you make an autonomous board and you follow the white track on the black part. I would like to mention this competition was again a big success. Around 50 teams, freshman teams completed the track. There were around 100 teams trying to make it, but 50 completed it, which is a good number. And on this first competition, like the circuit simulation and implementation, Arduino coding, digital electronics, we have them every year. Another major set of competitions are the tech fairs. Like, how many of you have participated in any competition in tech fairs? Last year. Which one? Crickbot, the image processing one. Okay, in the exhibitions, okay. So tech fairs, there are around 6 or 7 competitions with prizes worth, 60,000, or the big one go up to 1 lakh. So I would say, you just look at these competitions, see if you can form a team and try to participate. We do that via the winter workshop. The last point, winter workshop. We hold this workshop usually in December, where the main focus is on participation in tech fairs. So and no, it's not all work, and there's play too. So we have these interesting sessions like the Kinect one. We just had a session where we played games on Kinect. And there's these tech treasure hunts, tech fairs, and lots of treats. About the piano stairs, I'll see a short video at the end, then we can get back there and work with it. So these are the online, our website is quite active. You can find all the activities, all the upcoming events, the previous archives there. There's a tech ID part, which we've introduced this year. Well, you will not be able to access that. It's like we have given a identity to all the students of IIT Bombay. Where they can log in, they can register online for all the events. So it's very simple. You don't have to fill up a Google form with your name, your partner's name, your roll number, this, that, every time. You just have to go there, click, and you're registered. And wiki pages. We have a good pool of resources online. The documentation of the ITSP, like you can find it on this link. As I mentioned, we have a very active Google group or Facebook pages. About the video. Piano test. First I'll tell you about it. Has anybody seen the video where there's an escalator at the side and there's a stair? People have built a piano on it and people ditch the escalator and climb on the stairs because it makes sounds like a piano. And there the funda was you're trying to save energy because not anybody uses the stairs this time. So we practically did that. We built a piano on these stairs.
I'm never grown up to the electronics club. So we were able to do the first delivery that we have, which is called the piano stage. We have to believe that kids will get more interested, more fun, by making players of piano. You must be seeing all the time, right? No. So what we were want to do is that you want to make a set of stairs. You want to recognize the sound, right? And you can be sure that you will use the session to electronics. So people who don't want to study in the world of 30 years, so this is something we do. So what we have as our basic system is a sensor that detects the steps on a particular stair. A microcontroller you can call a black box that will detect the step has been stepped on, and the speaker is producing the sound corresponding to the step. So that is what we have. We'll be going to the demonstration, and also we will be asking Club-AAQ75 to see what kind of cloud they have and how they integrate it. Thank you. APR actually a particular processor to scale up the intake and real input. So, as you can see, as I do apply some pressure on the ammunition, the people sensor gets stressed of a different difference is generated, which is analyzed by the microcontroller APR32. That's the that analyzes it, tries to make some harmonic and passes on the digital step up and step down signal to the piezo buzzer that we have used. So right now, we have a metallic plate, as you can see, the golden color is a metallic plate. Taking the 12 volt source to the
Okay. We made these stairs again last weekend for an alumni event, and instead of just a PPP, we made Angry Bird sounds on it. So it was all the more fun. Anytime you step on it, it's like you shouting out. And yeah, we had an exhibition of the summer projects that were made. So these are some of the projects.
Hello, my name is Sagar, and this is the project that I have created during the Institute Technical Summer Project. This is an attempt at creating a system capable of polyphonic sound generation, meaning that it should be able to play more than one note or tune at the same time. And also for any musical instrument.
Have all of you seen the Sony Aibo dog? It's a very cute dog, it's a robotic dog, which can go, it can sense objects and it can pick them up. So here's I guess a better version of it.
Hi everyone, I'm Deepak and I'm a BTech second year mechanical engineering student, and this is my project that I've made the Eno 2.0. So this is the project ITS for ITSP 2012, and this is a quadruped dog. So it has 4 thigh joints and 4 legs. I've been using 9 servo motors for this project, and with 8 are for the movement of the joints and 1 for the neck joint. This is using an infrared gas sensor. This can measure distance from 20 to 150 centimeters. And I've been using Atmega T28 as the microcontroller. And I will give a small demonstration of so what actually this is doing is it is right now searching for objects, and we get an object in the range of less than 50 centimeters. It follows the object. Like right now it follows my leg, and if I move away from it, it tries to follow me. And this can even perform autonomous tasks like walking in different styles, taking a 0-point turn, and like moving sideways. It can even perform vector motion so that it can move in a 45-degree line. So it can perform jumps of 3 types, and it can even sit in many possible positions, and it is So actually the demo, fine. So actually the searching algorithm is like, it searches at an angle of 0 to 180 degree angle plan, and it starts searching from 0 degrees. It's like, it searches in an angle of depth of 3 degrees and 3 degrees. So actually it searches in the first 3 degrees, searches for the object. And it doesn't get any object, it searches for another 3 degrees. At any point if it searches for an object less than 60 centimeters its range, then we set an angle theta to the microcontroller. So actually the voltage, the output coming from the charge sensor is in the form of a voltage in between 0 to 5 volts. And what I do is I use a calibration formula to calibrate it in the form of centimeters. So I get the values from the charge sensor in the range 0 to 150 centimeters with an error of 2 to 3 centimeters. So in this case, when it searches for an object, the loop changes to a follow loop. So in this case, the theta values that it generates are used for generating parameters for it to follow the object. Generally, the parameters are like the left side is controlled with the parameter for u, and the right side is controlled by the parameter for v. So r and theta are manipulated in such a way that we get proper values of u and v, so that the board itself decides what radius of turn, how many steps, and what turns it has to take in order to reach the object. So that is the searching algorithm and all. And for moving sideways in the vector motion, what I've given is just a parameter kind of a motion. So if I put the parameter 30, it moves friends with a medium speed. And if the parameter changes to be 20, 30, then it takes the differential term with a specific radius. So this is how the turning works around x.
It's like a real dog. He's even calling those 4 friends as thighs. Yeah, so that's about it. Any questions? And all these session videos, we'll open source them. Like, we'll make a video portal of it where you can access all of them. And even in these sessions, if you're from Bombay, okay, even if you're from outside, you can join in, you can attend any of these sessions. You're welcome. So. Yes, that's what. We're not invited them, but recently 1 or 2 students from outside have come in and we have allowed them. So if you want to come in, you can, yeah. they're all within 1500 to 2000. Like mainly like this dog, mainly the servo motors had the cost. So even if you use 9 motors, that's 1000, and overall mechanical, everything 2000 max. Yeah, we have these mechanical labs in IIT Bombay. They can help you out, or yeah, mainly everything is done in the campus. No, we don't need bigger projects like the Technovation which I talked about. They have bigger projects like the Ornithopter is being made now, the TumTum tracker. TumTums are the buses, internal buses which we have. So we are making a TumTum tracker which can, track where the TumTum is at every position. So these big projects, they don't exactly come under electronics club. They're under SAB, but they're going on parallelly. These are made by the first year students after the first year. So yeah. No. Okay. Thank you. So, welcome.